Hi everyone, today we are gonna start with a new video. I have been working on this presentation, questions and code examples for more than over 2 weeks, and finally it's ready, and now I start to record the video. I hope you will like it, I hope it will be useful for you, and don't forget to click subscribe and like button if you do. So this video will be about around 60-70 Java questions and the answers to the questions with code examples. This video is very structured, so it will help you to be ready for your Java interview. If you already know these topics, if you already know these concepts, that's perfect. This video will help you to refresh those knowledge, and you will have those moments, aha, that's what it's about, or like if you have seen the interview questions, you will know how to answer those questions if you watch this video. Let's start preparation without wasting any time, and good luck. I am sure you have seen this question. What is the difference between JVM, GRE and JDK? The best way to prepare for this question is to have a table of the comparisons. So when you are asked these questions, the most important thing is to compare them. JVM, as you know, it stands for Java Virtual Machine. It runs Java bytecode on any platform. It converts the Java bytecode to the machine code at runtime. And it's also one of the reasons that Java actually is platform independence. It is write once and run everywhere. An example use you can give that it is for running Java applications. But when it comes to the Java runtime environment, it provides the libraries and environment for running Java applications. So that means that it contains JVM and also other core libraries. And it ensures that you can run Java even without compiling code. That's what Java runtime environment for. When it comes to the JDK, you have heard it a lot. I am sure that when you were trying to install Java, you have heard a lot about this Java development kit. What it does is it gives you like a complete toolkit for Java development. It contains GRE, it contains all these development tools like a Java-C, which is Java compiler. So now we learned that JVM is Java Virtual Machine, GRE is Java Runtime Environment, and JDK is Java Development Kit. Let's move to the next question. So our next question is about explaining different data types in Java. When you get this question as an interview, do not rush to explain primitive data types like int, float, double. First, try to start from the beginning. And the beginning means Java has two main data types. One of them is primitive data types and the other one is reference data types. After this, you can start to explain what primitive data types means and what reference data types means. So now you can explain what primitive data types are at first. So you can start explaining byte. So byte is, of course, the size is 1 byte, as you know, and it starts from -128 to 127. Of course, you don't need to memorize all this. For example, for short, for int, for long, float, double, for all of them, there are like ranges, right? So you don't need to really memorize. So you need to understand the important parts, like how these ranges are calculated. Why the range starts from -32,768 until 32,767. And the reason is that if we check the int, for example, now, you see, since int is 4 bytes and 1 byte is 8-bit, as we know, and since 1 bit, the first bit is for the sign, so if it is positive or the negative, as you know that binary can be like signed binary and unsigned. Since the first bit is for negative and positive, so it's for the sign, that's why the rest of the 31 bits is to represent the actual number in binary. So you need to understand these important key factors: 4 bytes, 8 bytes, and also how to calculate, as I said, the range. Sometimes they may not ask this question at all, but it will be very useful to understand this. It's not only about the interview, but generally, if you want to be a Java developer, just try to understand how this is interpreted. Perfect. And of course we have Boolean, we have false and true for this. That's why it's 1 bit. And we have char, which is 2 bytes. And store a single character. Perfect. Now let's have a look at our example code. As you see here, I have included how to have the int and double, Boolean, and also char. So, and I have used just simple system out print line to print them. This code example is just to visualize. So let's move on to reference data types. So reference data types, as it seems from the name, it is not about the actual data itself. It is to store the reference to the actual data. So that means that this reference data types is for storing the reference to the memory where the data is residing at the moment. So reference data types can be different. It can be like classes, like user-defined data types, interfaces, abstract data types, and arrays, which is a collection of elements of the same type. If we give one example to reference data types, you see that like we have one string here. That's also considered reference data types because, as you know, that string is not primitive data type. Some people confuse it, but try not to list string as a type of primitive data types. It is reference data type. And also array, it's also reference data type. And we have used just simple system out print line to print them. So we are not doing anything complex. Perfect. Let's move to the next question. So what is JIT compiler? This is one of the questions that you sometimes get in the interviews, but not always. So that's why it's really great to be ready for this question. That's why I have included it in our interview preparation. So if you recall, we have discussed in previous slides that what is JDK, what's GRE, and what's JVM. So as you see in this diagram, JDK is covering GRE, and GRE contains JVM, and JVM, which is Java Virtual Machine, it contains JIT, just-in-time compiler. So what is just-in-time compiler? Just-in-time compiler, as it seems from the diagram also, it's part of JVM that compiles bytecode to the machine code at runtime for better performance. So what it means? It means that it optimizes the execution of frequently used methods. So by this, it provides significant performance improvement for long-running applications. So these definitions and also explaining the relation between JVM and just-in-time, as we see in the diagram, is enough to answer this question in the interview. So do not forget that it is part of the JVM and it compiles bytecode to the machine code at runtime for better performance. So that is all aim of the just-in-time compiler, better performance. Now one of the famous questions in Java interview, what is wrapper class in Java? So as you know that we talked about int, double, char as a primitive data types, right? But in Java we have wrapper classes. They are used to convert primitive data types into objects. And that's useful in the scenario where we want to use objects instead of the primitive data types. Like we can take, for example, collections like array list, or we want to work with objects rather than primitive data types. Because as you know that the primitive data types, since they are not objects, they don't have any functions. They don't have any methods. So that's why they are not always useful. They are sometimes useful. Of course, it depends on the scenario that we are using them. But sometimes we need wrapper classes for those primitive data types. So that means that, for example, if you want to use int, but inside the array list, we will see also what array list is and blah, blah. We will talk about them, of course, in the coming slides. But if you want to create array list and inside the array list, you want to have integers, you cannot use int. You need to use wrapper classes which wraps that primitive data type. So that's why it's called wrapper classes. Double, and you see that they all start with capital letter. Double is a wrapper class for primitive data type double, and in the same way character is a wrapper class for char. And let's look at the example we have written here. So we have int, right? Int num is equal to 10. It's primitive data type, and we want to have integer of this primitive data type. The way that there are actually different ways, but one of the ways is to use value of method of integer. So if we send this primitive data type inside this method, then it will be converted to the integer, which is wrapper class for this primitive data type. So you will have integer object of this primitive data type 10. You can do opposite also. So that means that if you have this integer object, you can use this int value method to convert it to the primitive data type. If you are going to the interview, please memorize them, value of and int value, because sometimes in the interviews you will also be asked to write some codes, some data structures, algorithms. So depending on that, in most of the situations you might need these conversions and you will find them useful. Perfect. Let's move to the next question. Differentiate between instance and local variables. So instance and local variables, what are the differences between them? Let's first start looking at the example code. As you see here, we have age in two places. In two different examples. In one of them, we have defined it inside class, but outside the method, display method, right? But in the other one, we have declared and initialized it inside display method. So that is the main difference between these code examples. In one of them, age is instance variable. In the other one, it is local variable. So it should be local variable instead of instance variable. So the difference between these code examples is that this age variable is only, in this example, is only recognized inside this method. So if you want to use it here, for example, in some places where outside of this method, you will not be able to use age because it is local variable to this method. Okay, so but on the other hand, what instance variable means that you define it in the class outside some methods, so it's not like limited to the method. So that's why you can use it across the class anywhere inside your class. That's why it's called instance variable, and for every object of this class, this age will be available to use for every instance of this class. So let's read the definition also. Instance variables, as I said, they are declared inside the class but outside any method. It is specific to instance of a class, so it means it's specific to an object, meaning each object gets its own copy. So every object will have this age variable as its own copy. Its life cycle depends on the object itself. But on the other hand, local variable declared within a method or block of code, it can be also like there can be some local variable inside for loop, for example, not directly inside the method, but for loop, for example, inside the method. So then that variable will be local variable for that for loop. So it will live until that for loop will be executed. It only exists during the method's execution and must be initialized before use. Okay, so that's also one important factor. You cannot use local variable before initialization. Let's move to the next question. So why is Java not a pure object-oriented language? This is a little bit tricky question. You may get this question in the interview that they can check your understanding of object-oriented programming. And it has really easy answer. Java is not a pure object-oriented programming language because it uses primitive data types like int, char, boolean, which are not objects. We have discussed this, right, in the previous slide. We said that primitive data types are not object, they just hold a value. So that's why, since Java has these primitive data types, in a purely object-oriented programming language, everything should be an object. So that's why this question is interesting and a little bit tricky question, right? Since we have primitive data types, Java is not a pure object programming language. The next question is, what's a class variable? So class variable, do not confuse it with instance variable, right? In the previous slide, we talked about instance variable and local variable. This is a new type, which is class variable. It is declared using keyword static. Public static int count is equal to 0. So that is our example. But this static part is a key here. It must be used if you want to create a class variable. So one characteristic of this class variable is that it is shared among all instances of the class. What does it mean? In the previous example, when we looked at the age variable, we said that instance variable, every object has its own copy. There can be some other object that, for example, age will be 5 or age number will be like 20, 25, different values, right? But the main thing about these class variables are they are shared among all instances of a class. If one instance of class, for example, count is equal to 0, since these class variables are not instance variables, so they are not defined for object instance, but they are defined in the class. So it is common to all objects. And this already we have mentioned, changes made to it are reflected across all instances. So if, for example, let's see our example. We have here, we create one object, right? And you see that in our constructor, every time a new object is created, count is incremented one by one, right? So here, when we created this object 1, we will have count plus 1, so it will be count will be 1, right? In the second step, when we have this second object created, we will again increment the count, but this time count is not 0, right? We said that this static variable is shared among all objects, so we already count was 1, so when we create second object, it will be 1 plus 1, so it will be 2. So as you see here, when we call example.count, we will have output of 2. And one more thing to pay attention here is that, as you see, we don't call .count on the specific object, but on the class. So we write the class name dot this static variable. So this is class variable. Class variable is shared among all instances of a class, and unlike instance variables, they are common to all objects. Perfect. Let's move on. The next question is, what is the default value stored in local variables? Again, as a reminder, local variable is variable that is defined inside method or in some if-else condition or inside for loop. So they are not defined in the class outside method, but they are defined inside some method. So let's see what's the default value. So if you remember, when we were talking about local variables, we mentioned that local variables must be defined and initialized before we use them, right? So that means that local variables do not have a default value in Java. they must be explicitly initialized before they are used, or the code will not compile. So what does it mean? It means that, like, for example, instance variables, if we have, for example, int instance variable, int age, let's say, if we do not initialize it, it will have a default value of 0. But for local variables, that's not the case. We cannot say that, okay, int num, and we can't think in a way that, okay, since int has default value, we will have 0 here. No, that's not the case. Local variables must be explicitly initialized. Only in that case we can use. That's also one of the tricky questions, so be careful if you are asked this. Because they can also ask, like, for example, what is the default value stored in instance variables, right? So be ready for this. I think we already talked about this difference between instance and class variables, but let's revisit it again as a separate question, right? Instance variables, they are defined inside a class but outside a method. We have already mentioned it. And each instance of the class has its own copy of the instance variable. But class variables, on the other hand, has static keyword. They must be defined with static keyword, and they are shared among all instances of the class. Perfect. Let's move to the next question. Explain the difference between these two types of right shift operators. They can be asked in interviews, but more important than that, you will need to have this knowledge in order to solve a bunch of questions, a bunch of problems that you might be asked either in online coding or in job interviews in different places, right? So that's why we need to have at least this basic knowledge. So the first one is called arithmetic right shift, and the other one is called logical. That is the difference with their names. But as an operator, the main difference is that arithmetic right shift shifts bits to the right, and it fills leftmost bit with the sign bit 0. Either it is 0 if it's positive, or 1 if it's negative. So that means that for arithmetic right shift, there is one bit which is on the leftmost. So that means that the first bit, for example here, this one, leftmost bit will be sign bit. So it will be preserved for the sign of the number, either it is negative or positive. But on the other hand, this operator shifts bits to the right, and it fills the leftmost bits with zeros regardless of the sign. So logical right shift does not care about sign bit, but arithmetic right shift cares about the sign bit. So that's why it preserves 1 for the sign of the number. So for these operations, you will notice the difference only when the numbers are negative, right? Because if they are positive, then they will be converted to the same numbers as you see here in the example. For example, if we have, for example, 16, right? 16 means that 1 0 0 0 0 in binary, right? It means 2 power of 4. So if we right shift it 2 places, 16 will be 4. You know why? Because this one here in this place will be shifted 2 places to the right, so it will end up here. So that's why it will be not 16 but 4. It is the same with logical operator also, logical right shift operator. So because this number, this input number is positive number, we will not have any difference. But if it is negative number, then we will have a difference. So if you check here, the result of the arithmetic right shift is the same number. It is now negative 4, right? But if you check what happens with logical right shift, see what number we will get. And the reason is that, you see, minus 16 is defined like this. And in binary, if we have this minus 16 defined like this, if we move bits 2 places to the right with logical right shift, then we will make this leftmost, this bit here, which is sign bit, right, this bit 1, we will make it 0. Because as I said, logical right shift does not care about sign. Regardless of sign, it makes it 0. So that's why it will become this number at the end. If you know these basic differences, you will be alright in the interview. So let's move forward to the next question. What are the differences between string and string builder? So in order to know the difference between string and string builder, first you need to understand what's mutable and what is immutable. Mutable is that when you create a new object in the memory, if you can change the value of it, the content of that object, if you are able to change it, then it means that that object is mutable. So that is, how can I say, that's modifiable, right? But if an object is immutable, that means that once that object is already created in the memory, there is no way to modify its content. So if we go back to our question, the difference between string and string builder is that string is immutable. Once it is created, you cannot modify its content. So if we check our code example here, you see that we create a string and the value is test. There is no way, as soon as it's created, there is no way to modify the content of this object. Because you know that when it's created in the memory, this object is created and the value is test, right? The content of the object. And this s variable is referencing to that memory. Of course, you can update that s reference to some new object which is called new test. So this still exists in the memory with the value, with the content test, of course, until garbage collector removes that object from the memory. When it comes to string builder, let's see our example actually. We create an object, and when we have the object, and this is the reference to that object, of course, string builder, you see we use append. Actually, string builder has many different methods, but for this example, we are using append t. So that means that we will append a new character. So first we will have this t and e and s and t, and then we will have test, right? So you see at every step we modify, we change the content of the object we have created, right? That's why string builder is mutable. This is main difference between string and string builder. Of course, when it comes to the performance, string is a little bit slow because, as you know, since we cannot change the value content of the object, we create a new, for example, new test, right? So that's why the performance is a little bit an issue there. But string builder is faster for modifications. So the use case, of course, is that string builder is used for dynamic and frequently modified text, but not string. Perfect. Let's move to the next question. As you know, there are two ways to create a new string. One is to use literal, and the other way is using new keyword. So the question is, what are the difference between these ways? So we have the code example here. In one way we create a hello using literal, but in the other way we create it with using new keyword. So the difference is that when we create a string using literal, it goes into the string pool. So what does it mean? It means that if a string with the same content already exists, Java will point to the existing string to save memory. Let's say we create hello. So this hello will be added to a string pool. And when we try to create new object with this hello literal, Java will check, does this string already exist in string pool? If yes, it will reuse the same string from the pool, so we will not have a new created object. So that's why it will save memory. But new string, on the other hand, it creates new object every time in the heap memory. Don't forget that. Even if the string already exists in the pool, it does not care, because new keyword means that create a new instance, right? So that's why it will create a new instance, and we will have a new instance of this string with the value hello. Perfect. That's also one of the famous questions, so try to keep it in your mind. Let's move forward. So now the next question is, what is the difference between equals and equality operator in Java? This is also a frequently asked question. So the difference is that equality operator is only checking the memory address, so the references of the object, right? So that means that it does not check the content. It checks that, for example, if we have two objects, or let's say if we have one object and we have two variables, right? Let's say if it is A and it is B and it is B. So it checks if A and B, both of them is pointing to the same object in the memory or the same memory address. That means that this equal operator will return us true. So if A is equal to B in this scenario, it will return true. If they point to the different objects, then this operator will return false. But when it comes to the equals method, it compares the content, not reference. So it is used to check if two objects are meaningfully equivalent based on the attributes. So that's why when we are comparing two strings, so it is especially important to remember this for strings also, because that's one of the interview questions, and also when you are solving some programming problems, you will need to know the difference between equal operators and equals method. So if let's check our example code. You see we have two strings A and B, hello and hello, both of them are the same. But when we are checking the equality with equality operator, it will return us false. Why? It's interesting, of course, because we would be surprised that even the content is the same, both of them are hello. Why we are getting false here? It is because when you create a object with hello, one object is created, right? But we said that new keyword will create another object, even the content is the same, right? So we will have another object in the memory. So we will have one and two objects. So when we are using equality operator, it will check for the reference, and since they have different references, different memory addresses, it will return false. When we are checking with equals method, what equals method is gonna do is it will check the content of these objects. So that is why it is important to know the difference. Perfect. Let's move forward. And before we move to the next question, I would like to ask you, if you like this content, don't forget to subscribe and like or give any comment. Let's move without wasting any time. And the next question is explain stack and heap memory. So when I was creating this list of questions for my presentation or for my video, I was trying to choose the questions so that they are real. They will be asked in interviews. So that's why do not try to skip some questions, and I assure you that there are high probability that you will get this question in the interviews. So stack and heap memory. Stack memory, it stores primitive variables like int x, right? Heap memory, it stores objects like, for example, memory demo, or like a code example as we have here in the code. So the main difference is that heap memory are responsible for objects, but stacks stores a primitive variables and also references. What does it mean? It means that here, if we look at our example first, int x is equal to 10. This will be stored in stack, okay? There is no exception about this one. But when we come to this object instance, or like a memory demo, if we have this kind of object, when we have this new code example object instance, the object itself is stored in heap. But there is one catch here, one tricky part. This variable itself will be stored in stack. Do not forget this difference. This is very important. So if we check our table, stack memories also stores method calls and local variables. This is also important, of course. We didn't mention it, but it stores method calls. And heap memory stores objects and instance variables too. We already know that because if it stores objects, of course, in the memory, and object contains instance variables, so that means that memory will have both of them. And the size of stack memory is fixed, but heap memory is like dynamic size. It has like a larger memory allocation, let's say. And the way they work, stack memory is last in, first out. You will probably have used stacks in Java, right? Stack and queue. So I don't want to confuse you, but they both have last in, first out access method. Heap memory, there is no specific order, accessed via references, right? Whenever they are called, they will be accessed from heap memory. So for the stacks, memory is managed. I mean, they will be like cleared, memories will be cleared when the method finishes. I mean, we are talking about stack storing method calls. But for the heap, it is managed by garbage collector. So this is important to know, at least like the name of the garbage collector. I mean, the concept of garbage collector. Garbage collector will freeze the memory of the objects which are not used or referenced any longer in the application, right? So heap memory is managed by the garbage collector. When this, for example, this object, new code example, if it will not be referenced anymore by any reference, any variable, not only by this object, but any variable inside the application, then this new code example object in memory will be ready for garbage collector. And when garbage collector decides to release the memory that this object occupies, then it will remove and it will release that memory. So there is no way, to know when garbage collector will collect that and will release that memory again for the use. So this was just like a one side note. So let's continue. Stack memory has a faster access and allocation, but heap memory has slower memory access because of this like a dynamic allocation. Yeah. Perfect. Let's move to the next question. On which memory are arrays created in Java? It's important to understand that arrays are created in heap memory. And the reason for that is that we have already mentioned that all the objects are stored in heap memory. Heap is a part of the memory used for dynamic memory allocation. And as I mentioned, since arrays are objects, they are stored there. And this is also important part we have already talked about. The reference to the array is stored in stack memory, but the actual array data lives in the heap. So that means object itself in the memory will be in heap memory, but reference to it will be in the stack. Perfect. Let's move to the next question. So our next question is, what is a constructor? You have heard a lot about the constructors, but let's see how we can explain it in the interview. So a constructor in Java is a special method to initialize objects. When we have this like a classes in Java, they all have constructors. Either they are explicitly defined by us, by developers, or they will have default constructors, right? So A constructor in Java is important to initialize objects. And one of the key characteristics is that it will have the same name as the class and it will not have any return type. So if we look at this car example, car is a class, so it's a blueprint. So it has this instance variable which is model, and it has also constructor, right? It doesn't have any return type and the name is the same as class name. And if we look at how we create the object of this class, we write new car and we send this model name Tesla inside this constructor, right? And if you see, we have constructor argument here, and that's how we create the object of this car. So that's it about the constructor. The most important thing is to be able to explain that constructor is used to initialize objects. It has the same name, doesn't have any return type, and they are called when an object of the class is created. And also do not forget that if we do not define the constructor ourselves, still a class will have constructor, which is default constructor, right? Perfect. Let's move to the next question. What happens if you don't provide a constructor in a class? We more or less answered this question, right? Just 1 minute back. So we said that if no constructor is provided, Java automatically provides a default constructor that initializes the object with default values, right? Either it will have null for objects or like a 0 for numbers or like for different primitive types, different default values. But that's not important for this question. For this question, the most important thing is that if we do not provide a constructor, it will still be there. So every object has a default constructor. Without a constructor, we cannot have any object, right? Let's have a look at the example here. We have my class, right? But as you see, we haven't defined any constructor. We have only defined age instance variables, that's it. But still we can create instance of it, right? Because we are using default constructor. Default constructor does not have any constructor input argument, because as you see, we don't send any input argument. Let's move to the next question. What is this keyword in Java? So this keyword in Java is used when we refer to the current instance of the class. So what does that mean? So that means that, let's see here, we have example code class, right? And we have this constructor, we have already talked about it. When we are using this keyword as here, this num is equal to num. That means when we create object, look at here, we create the object with value 5, right? When we send the value here to the constructor, we are saying that this class num instance variable will have the value that comes to the constructor. That's it. So that means this keyword is used to refer to the current instance of the class. What is an interface? So an interface in Java is a blueprint of a class. So it contains abstract methods and also like a constants variables. So first we need to talk about what is abstract methods. Abstract methods are methods without a body. It has only like method signature, right? So interfaces in Java is a blueprint of a class. That means that interfaces will define methods that the classes which will implement those interfaces must have those methods. That's why we are saying that interface in Java is a blueprint and it contains abstract methods. Interfaces are used to define a contract. So I have already mentioned, when classes are implementing interfaces, they must have those certain methods which interfaces have defined. And also it is a way to achieve abstraction and multiple inheritance in Java. What does multiple inheritance mean? So in Java we have parent and child class, and child class can extend a parent class. But the thing is that child class can only extend to one class. So every class can have one parent class or no parent class, of course, but maximum is one parent class. But interface gives us an availability, flexibility that we might implement multiple inheritance. So we are not limited to only one interface, parent and child class. This doesn't give us multiple inheritance, but we can get something similar inheritance by using interfaces. So let's look at our example here. If you see here, we have animal interface and it has one abstract method. So abstract method have just the return type and the method name. So method signature, let's say, right? But it doesn't have any method body. The body will be defined by the class which implements this interface. We are saying that dog implements animal interface, and when we have this dog, we must have this sound method with the same return type, and it must have a body. So the advantage of using these interfaces is that when we create a dog class, since animal, we said that an interface is a blueprint, it will not compile if we don't have this sound method. That's why it is said that this is a contract. Interface is a contract, and the class that implements it must have those certain methods. Perfect. Let's move to the next question. So let's start with the next question, and it's about differences between abstract class and interface. Actually, the main difference is when it comes to the method and method body. When you have abstract class, in abstract class you can either have method with body or without body. It means either you can have abstract method or concrete method. So the difference between these methods is that, as I said, it's one is without body and one with body. But for interfaces, all methods are abstract by default for the version Java 7 and below. But for new versions of Java, you can still have both abstract and concrete methods. And when it comes to the multiple inheritance, abstract class supports single inheritance only. As I have also mentioned in the previous questions, when it comes to the inheritance between subclass and superclass or child class and parent class, you can only extend one class. So you can have only one inheritance. So that's why it is saying that abstract class can have a single inheritance, but when you have interface, you can have multiple inheritance. So you can implement multiple interfaces with one class. So that's why the difference is multiple inheritance, one of the differences. So one of the main differences is that abstract classes does not support default methods, but interface does. And what is default methods? Default methods is that we know that when you have abstract methods inside the interface, I mean methods without any body, the classes which will implement these interfaces must have those methods implemented, right? But when you define the method as default method, then the implementations, the classes which will implement those interfaces, do not need to implement those methods. So those methods will be directly inherited by its implementations. And when it comes to the variables, abstract class can have instance variables, but in interface, variables are public, static, final. So you also need to keep it in your mind. And we have already mentioned that the usage is that used for shared between subclasses, but when it comes to the interface, it defines a contract for implementing classes. Let's move to the next question. What are the main concepts of object-oriented programming in Java? So the next question is, what are the main concepts of object-oriented programming in Java? Let's start with encapsulation. I am sure that you have heard about it a lot. So encapsulation is one of the concepts of object-oriented programming in Java. Encapsulation means wrapping data and code into a single unit called a class. That's one of the encapsulation. So when we say that encapsulation is one of the main concepts of object-oriented programming, we don't say that there is only one way to achieve encapsulation, but there can be multiple ways to achieve encapsulation. And one of the ways is wrapping data, that means using variables, and code methods into a single unit called a class. And the second way to achieve encapsulation is the variables of a class will be hidden from other classes and can be accessed only through the methods of the current class. Therefore, it is also known as data hiding. And I will explain you what this sentence means. I don't know if you have used or not, but if you check here, we have getter and setter. And if we check this variable, it has been defined as private. So that means that this variable cannot be used by other classes directly. If you wanna get the value for this name variable, you must use this getter. And if you wanna set a different value for this variable, you must use setter, right? There is no direct way to change the value of variable because it has been marked as private. So that's what this line means. The variable of class is hidden from other classes and can be accessed only through the methods of the current class. And in order to achieve encapsulation in this way, we need to declare the variable of the class, or if there are many variables, all the variables must be declared as private, and we need to provide setter and getter. Let's move to the next concept of object-oriented programming in Java. And that we have already talked about, it's called inheritance. Inheritance is acquiring the properties of one class by another. We have already looked at many examples of inheritance. One is superclass and subclass. In this code example, you can also see that we have animal, which is parent class. In other words, it is superclass. And we have subclass dog, which extends superclass animal. So that is called inheritance, because dog extends this animal, and through inheritance it acquires properties of animal class. So you see here, it overrides void sound method. Advantages of inheritance. What is the advantage of inheritance? Why we should use? One is code reusability. The code written in superclass is common to all subclasses. So if we were happy with this sound method, it wasn't a must to override that method, right? So there could be some other methods. So let's not take sound as an example, but there could be some other methods. For example, eat, right? There could be eat method. All animals, we can assume that all animals eat some food, right? So that means that if there was some methods that we don't need to implement or override by other subclasses, we can use the method of superclass, right? So it's not important to override it if we don't need to. So that's why it says that code reusability is one of the advantages. There can be some cases that you can write a code in superclass and it would be common to all subclasses, and child class can directly use parent class code. The other advantage is method overriding. We have already looked at that example. Method overriding is achievable only through inheritance. It means that in subclass you try to override the superclass method. It is one of the ways by which Java achieves runtime polymorphism. This is also something that you need to remember, because during runtime, only that time Java understands which sound method it is gonna call. Is it gonna call subclass or superclass? And one of the advantages is, of course, abstraction. The concept of abstract, where we don't have to provide all details, is achieved through inheritance. Let's move to the next concept of object-oriented programming in Java, and that's called polymorphism. We have already mentioned this concept. Polymorphism allows you to define one interface and have multiple implementations. When we say one interface, it doesn't mean that the interface that we have already discussed. It means that either you can have interface or you can have parent class, and subclasses can extend that parent class. And advantages of polymorphism is it increases the code reusability. So when you extend superclass parent class, you can use the parent class methods in the subclass, right? We have already talked about it. And it improves readability and maintainability. So it is because we reduce the amount of the code. That's it about polymorphism, and we have the example here, the same example. Let's move to the next concept of object-oriented programming, which is abstraction. As you see here, most of the concepts are interrelated, right? We have already mentioned this abstraction, hiding complex implementation details and showing only functionality, right? Abstraction in Java can be achieved through interfaces or abstract classes where we have default methods, right? So as you see here, we have abstract class vehicle, and it has abstract method starts without any body. So then we extend that vehicle abstract class and add the implementation there. Perfect. That will be last concept of object-oriented programming. So don't forget these keywords: encapsulation, polymorphism, inheritance, and abstraction. So the next question is, what is the difference between static method and instance method? I know that we have already mentioned that static method is not per each instance. They are the same for all the instances of the class, right? So let's have a look what is the difference between them. As we have already discussed, static method belongs to the class, not to any object, right? And it can be called without creating an object because it's not belonging to any specific object. We can call it for class by using class name and dot static method name. It cannot access instance variables or methods directly, right? Because if you will try to use instance variables in your static method, let's say that, for example, here in example class, we have, for example, instance variable of age. If you try to use that instance variable in static method, it will throw compile error because you cannot use instance variable in your static method. And on the other hand, instance method, of course, belongs to an object of the class, can access instance variables, of course, and other instance methods, and requires an object to be called. So you cannot call instance method without calling an object. I mean, you need to have an object in order to call that object's instance method. So here, for example, this is instance method. So you need to say that example is equal to new example. So you need to have that object in order to call instance method on that object. But here you can directly say that example.static method. That's it. Perfect. Let's move to the next question. And with this question, interviewer will try to see if you understand this private constructor usage scenarios. So we said that if you want to instantiate the class and create an instance, object instance of it, you need to call private constructor, right? But if we don't want to have that instantiation of the class, we can create a private constructor, and what it will do, it will restrict instantiation of the class from outside the class. So if you see here, what we have done is we have created a private constructor. So with this way, it says that, okay, replace default constructor, right? So now we will have this private constructor, and we will provide getInstance method, which is a static method. We have already talked about these static methods. And what it does is it will create the instance of this class, and it will return instance if we call getInstance method. So what is it for? Why we need this pattern? This is called singleton pattern. It ensures that only one instance of the class is created. So what's it for? In what scenarios we need it? So if you have an application, and inside the application you are connected to the database, and this database connection class, you do not want to create multiple instances of it, right? Your database server will be overloaded with these connections, right? So that's why you need to limit the number of the instance of this database connection. So in that case, you can use this pattern, and whenever you call your get instance, you will only get one instance back. If it is null, of course, it will create a new instance. Otherwise, it will return you existing instance. So by this pattern, you will have only one instantiation of the class. Perfect. So the next question is, what are the differences between constructors and methods? I am sure that you only know the differences, but still, let's look at what we have prepared here for you. Constructor, it initializes a new object. We have already talked about it many times, but when it comes to the method, it performs a task or operation or function, whatever you call it. And constructor must have a same name as class name, and method can have any valid identifier. Typically describes the action. So it means that for the method name, you can choose almost anything. Of course, it should be valid identifier. So return type. Constructor doesn't have a return type, right? And method must have a return type. If it doesn't have a return type, it should have a void return type, let's say. And constructor is called when an object is created, but method is called by the object or class. So see these two different keywords here. So we say that either it's called by object or class. Why we have two options? Because we have already discussed that if you have static methods, then you can call it with class, right? You don't need to have the object. But if you have instance methods, then you need to create object first, and then you need to call method based on that object. And constructor is not inherited, and methods can be inherited. Let's move to the next question. What's constructor overloading? So we already talked about method overriding, and now another term comes up. What is constructor overloading? So we have already talked about method overriding. Now another term comes up, constructor overloading. So constructor overloading in Java, it lets you to have multiple constructors. But the main thing here is that constructor should have different parameter lists. With that way, you can enable the creation of object in different ways, depending on the arguments passed. And the constructors that match the number and the type of arguments is called. So let's have a look at the example that we have here. We have car, and it has two instance variables, model and year. And we have two constructors. So that means that there are two ways to create the instance of this class, right? So one way is we can call our constructor without parameter, and what it will do is it will say that year is 2024 and model is unknown. So it has some default values passed to these instance variables. And the other way is that we can send these both variables in the constructor as arguments, and we can have those values assigned to these instance variables. Let's move to the next question. So one of the most famous questions is, what is the easy relationship in object-oriented programming Java? So easy relationship represents inheritance between a subclass and a superclass, meaning that subclass is a type of superclass. As I have mentioned, you will see some repetitions, but the questions are asked in a different way, right? So if we can say that something is a something, that means they have inheritance relationship between each other. That means, let's test it in our example code. We have animal, which is superclass, and we have dog, which is subclass. Can we say that dog is animal? Right? We can say that dog is animal. It is correct sentence to say. But we cannot say that, for example, microphone is animal. So that means we shouldn't create a microphone class and extend animal, because they do not pass this easy relationship test. So if you are sometimes confused when and what classes are subclass and superclass, or even whether they have those relationships, try to check if they pass this easy relationship test. Let's move to the next question. Why is inheritance less advantageous than composition? So let's first check what is inheritance and what is composition. We have already talked about inheritance, so probably we will skip that now because we have talked about it a lot. Dog extends animal. Composition means that two objects or two classes are dependent on each other. So that means, so we have dog and we have sound here, right? So without dog object, sound cannot exist. So as you see here, we are using sound, and when we create this dog instance, we also pass sound as a constructor argument, and we also have this method which makes sound using this sound object. And what are the differences between them? So flexibility, when it comes to the advantages, flexibility comes to the picture. Composition lets you to change the behavior at runtime because it dynamically composes the objects. It means that when you are extending superclass, you are already binding them together at compile time, but composition is actually happening at runtime. And loose coupling. With composition, objects are loosely coupled, making the system more modular and easier to maintain. And also, when it comes to the hierarchy complexity, inheritance leads to deep class hierarchies. Let's move to the next question. What is runtime polymorphism or dynamic method dispatch? Runtime polymorphism is that when you override a class of superclass, the method call actually is resolved at runtime. In runtime, it is resolved that either you are calling, for example, superclass method or subclasses overridden method. So that is called polymorphism. And it has a different name also, dynamic method dispatch. It lets Java to dynamically choose which method to execute, of course based on the object type. So it means, for example, here we have my animal and it holds dog instance, right? So when we try to call my animal sound in runtime, it tries to check which method to call, either overridden or superclass method. And at runtime, it understands that, okay, this is the method because this is the object, because it is instance of the dog object. So then it tries to call sound method. Let's move to the next question. What is method overriding? We have already talked about it many times, but still let's see what we have prepared for you. Method overriding occurs when a subclass provides a specific implementation of a method, but that method also exists in superclass. It lets a subclass to customize, or like you might extend the behavior of that method, right? So you have a possibility to override that method in subclass and we have already talked about it, and I'm sure that this code example already is familiar to you. But there is two main things that you need to remember. Overriding methods, they must have the same method signature. It means that they must have the same name and same return type and the same parameters. If it doesn't have a parameter, the other one also should have without parameters. And subclass method is executed instead of the superclass. Already we have looked at many examples of this. Let's move to the next question. So the way this video is constructed, I have placed all the questions in the order that will be helpful for you to connect all the topics together. Because we have checked method overriding, now we are looking at method overloading. What is method overloading? Method overloading is a feature in Java that lets a class to have more than one method with the same name, but it must have different parameter list. It helps to increase readability of the code because you use the same method, of course, but method signature should differ. And you might ask that why we need to have the same method name. I mean, why we need this method overloading? There might be many scenarios that you might need this. You remember that even like actually constructor overloading example, right? We even can have some scenarios where you might need not one constructor, but different constructors with different parameters. So it is the same for method overloading too. If we check our example, we have add method and another add method, but with different parameters. So it is called method overloading. So the next question is, can we override the private methods? This is a really good question, and let's move to the answer. Actually, it's not possible to override private methods. And you know the reason, because method overriding is where the method in the subclass is implemented instead of the method from parent class, right? But if method in the class is private, then it will not be accessed outside class. So that's why it's not possible to override private methods. Let's move to the next question. This is also one of the common questions. Can we change the scope of overridden method in the subclass? And the answer is yes, we can, but in a specific way. And what is that way? And the catch here is that we cannot reduce the visibility of the overridden method in subclass. So if superclass, for example, is public, we cannot say that, okay, subclass will have method with, for example, protected or private visibility, right? However, we can increase the visibility. If, for example, superclass is, for example, package protected, we can make it, for example, public, but we cannot make it more restrictive. And we have also example here. We have protected void display method, and in our subclass, we actually make it public. But if we try to make it private, of course, it will result in compile time error, saying that we cannot reduce visibility. Let's move to the next question. Because we have already covered many concepts as a part of other concepts, this is kind of like a repetition, and I think you already feel happy that you already know answer to this question. But still, let's see. Abstract class cannot be instantiated directly. It means that since abstract class doesn't have, some of the methods might not have, for example, method body, right? It is just abstract class. Imagine that it is the same as interface. It's kind of like a blueprint, right? It is meant to be inherited by other classes where abstract methods must be implemented. When we say inheritance, of course, you already know that some other classes must extend this abstract class. So abstract classes are used when we want to define a common behavior where other, like a 1 or 2, 3 multiple classes will share. Abstract classes are used when we want to define common behavior, for example, abstract methods, but other subclasses can have their own implementations. Abstract class can have both abstract and concrete methods. We have already mentioned it. Abstract methods must be implemented by subclasses that we already have talked about, and abstract classes can have constructors unlike interfaces. We know that interfaces cannot have constructors. So if you see here, we have, for example, abstract class animal, and it has two methods. One is abstract, one is concrete method. And if you see child class, subclass, it overrides sound method, but actually it chooses not to override sleep method, and it's okay with this method, right? It can also override it, even like concrete method, but in this example we don't. So there is a possibility that we can just reuse superclasses method, but abstract methods of course must be implemented by child classes. Let's move to the next question. Now, completely new concept. Explain interfaces collection framework implements. The collection framework is one of the most used frameworks in Java. That's why it's crucial to know what it contains. Collection framework in Java contains interface, list interface, of course set, we already know that, queue, dequeue, and map. And of course these collections, they all have distinct features, methods, but we have given just one examples per each. For example, how we need to create list, probably you already know about it, and how to create new hash set, and queue, and map, of course. Perfect. Let's move to the next question. How does the size of array list grow dynamically? Let's talk about array, and then we can move to array list. We know that when we create new array, we must define the size of it, right? If we want to have 5 elements, we must define that this array size is 5 or 6 elements, 10 elements. So arrays have fixed size. But on the other hand, array list grow dynamically, because we know that when we create a new array list, we can add elements continuously, right? It doesn't have fixed size. So how does the size of array list grow dynamically? Because in interview, if they ask that what is the difference between array and array list, and if we say that array has fixed size but array list grow dynamically, right? Then the next question can come up, how it grows dynamically. An array list in Java grows dynamically when it reaches its capacity. So it means that Java internally use array to store those elements of array list. But when the array is full, it creates a new array with 50% more capacity by default. And it copies the elements from the old array to the new one and then adds new element. So what does it mean? What is the capacity? As far as I remember, it was either 12 or 16 elements. Let's move to the next question. So the next question is how to make Java array list read-only. What does it mean? It means that we might have some scenarios where we need to have unmodifiable array list. And of course we have a way to do that. Collections unmodifiable list method, it creates a modifiable view of the list. Any attempt you try to modify it, it will result in an unsupported operation exception. And we have a code example here. As you see, we create a new list, just ordinary list, and then we make that list unmodifiable list, so no one will be able to modify it. And if we try to add one more element to that unmodifiable list, to this read-only list, then it will say that it is unsupported operation. Perfect. Let's move to the next question. We know what's queue, right? Queue is first in, first out, and it can be created as linked list in Java. But what is priority queue? And the answer is that priority queue is a special type of queue, but it follows some order. And the order is defined by the element's priority rather than insertion. So it means that when we say that queue is first in, first out, priority queue does not care about insertion. It does not care about who is first, what element is first. So it doesn't follow first in, first out order. Instead, it says that element with the highest priority or smallest, if natural ordering is used, it means there is no custom order used. Element with highest priority is dequeued first. And key characteristic, we already said that it's not first in, first out, and ordering, it use natural ordering, or we can create our custom comparator, and it is non-blocking. That means that priority queue is not thread safe. So common methods are add and offer, the same as queue. Poll returns and removes the first element that is going to be dequeued. But pick, compared to the poll method, pick retrieves. It does not remove the head element. And we have an example here how we can create priority queue and how we can add elements to it. Let's move to the next question, and the next question is, what is linked list? The linked list class in Java is a part of Java util package, so don't forget that. And linked list in Java has doubly linked structure. That means that you know that how linked list works, like we have elements and every next pointer of each element points to the next element, right? But in doubly linked structure, you can also get the previous element with previous pointer. So that is how this linked structure works, doubly linked structure works. And dynamic size. Linked list can grow or shrink dynamically as it's not backed by a fixed size array, right? It is the same as array list. It is growing dynamically when you add new elements. If you want to learn how to solve problems using linked list, you can of course check my playlist. I have tried to solve different problems using linked list, but yes, this should be enough to answer the question about linked list. And I have included some examples here. As you see, we create new linked lists in Java in this way, and we can add first and add last. Because it is doubly linked structure, both methods are available for us to use. And of course, you can get first and get last, because as I said, it has doubly linked structure, and you can also in the same way remove first. Perfect. Let's move to the next question. What is stack in Java? And by the way, if you haven't done it yet, please don't forget to subscribe and like or give some comments. It will motivate me and I will create more videos like this. Stack is quite opposite of queue. In Java, stack is data structure that follows last in, first out. You know that queue is using first in, first out principle, right? But stack is, on the other hand, using last in, first out. And maybe because of the interview anxiety or you're nervous, you might mix up this last in, first out, first in, first out. The way to remember these principles is stack is, imagine that you are trying to put dirty plates in the kitchen. So you have one dirty plate and second, third and fourth, fifth and sixth. You have pile of many dirty plates. But when you try to wash it, the ones that you have put last, that will be washed first, right? Because you take it from the top. So that's how you can remember it. Stack is last in, first out. So you will not mix it up with first in, first out. This means that the last element added to the stack will be the first one to be removed. We have already mentioned it. And Java's stack class is a part of util package as linked list. And it provides methods to perform standard stack operations like push, pop, and pick. So we have also given an example here how we can push new elements to the stack and how we can pick. And since this is the one that we have added last, that will be the one that will be picked first. Pick, of course, as you know, it only returns you the element, it does not remove. but on the other hand, pop will remove 30. So after removal of 30, of course, the next one when we pick, it will be 20 because this element will not be there anymore. Perfect. Let's move to the next question. And the next question is, what is map interface in Java? Map interface in Java, we have already mentioned that it is part of Java Collections framework, and it represents data structure that maps unique keys and values to each other. Each key is unique, so you cannot have duplicate key. So you can look at here. For example, here Alice is key, 30 is value, and Bob is key, and Charlie is key. So you cannot have duplicate keys, but multiple keys can map to the same value, of course. Bob can map to 25, Charlie also can map to 25. Of course, here it's 35, but it can. The map interface is especially useful for cases where you need to store and retrieve data based on keys. Yeah, it's like a dictionary. Actually, I think in Python it's called dictionary. So common implementations of map is hash map and linked hash map and tree map. In hash map, there are no ordering of entries, right? Whatever you add, whatever you insert, you can get by key. So there is no order. It allows one null key, but you can have, of course, multiple null values. On the other hand, linked hash map maintains insertion order. And tree map, like entries are based on the natural ordering of keys, or if you provide custom comparator, it will be ordered by that logic. Perfect. Let's move forward. What is an iterator? An iterator in Java is an interface, and it will give you a way to iterate through a collection. It can be list, set, or map, and it's part of the Java collection framework, the one that we have already discussed in previous slides. And it allows you to access elements sequentially without exposing the collection's underlying structure. So that means if you use iterator, you are using iterator in the same way for list, set, or map. It does not matter which collection you are using. So we can see here is that we have example list, and the way to use it, you call iterator method on it, and you will be given this iterator. So then you can use this logic where you are checking if that iterator has next element, then you print it. So you will do it until it doesn't have any next element. So if you would like to do it for set or map, this part is kind of like fixed. You will create an iterator and you will use while loop. That's it. So that's why it says that it hides underlying structure. And it has this methods has next, which will return true if it has next element, and you can also move to the next element in the collection. Perfect. Let's move on. Differentiate between array and array list in Java. We have already talked about it. That's perfect. Now we will see their differences in the table. Array and array list in Java are used to store collections of data that we already know, but they have distinct features. And this we have already talked about it. Array is fixed sized, array list dynamic size. Arrays can store both primitive and object type, but array list cannot store primitive type. And we have already talked about it in the beginning of this video. And you know that we need to also provide size of it. So that's why it says that memory allocation is defined at compile time. For array list, it's allocated at runtime because you know that when you add new elements, it can be resized as needed. And the syntax are of course different. We will skip this part. And performance, when it comes to the performance, it's faster, but array list is a little bit slower. Access times like a big O complexity are the same. And by the way, if you want to learn more about big O complexities, of course you can visit my video. I will put some like notifications there so you can try to check big O complexity if you have a hard time to understand that concept. And of course, insertions and removal, ArrayList has some methods already given to us, but array doesn't have. And if you want to create like a matrix kind of structure to hold your data, and of course you can use multi-dimensional array, but ArrayList, you will need to create like a nested array list. Yeah, perfect. This we have already mentioned. So I think we can move to the next question. What is the difference between ArrayList and linked list? So ArrayList and linked list, the implementation is that one is dynamic array. It doesn't have fixed size. One is doubly linked list. We have already talked about this. But the main difference comes when it is about data access. ArrayList has random access O1 with get method. You already know that. But in linked list, it's a little bit slower. So random access will require O(n) complexity. And when it comes to the insertion and removal, it is slower if you want to insert in the middle. But in linked list, it has faster insertion and deletions, and it is O(1) complexity. And memory, ArrayList use less memory and linked list use more memory because it has pointers. If it is doubly linked structure, it has next and previous nodes. And when it comes to the performance, it's best for frequent access, and linked list is best for frequent insertions and deletions. When it comes to the thread safety, actually both of them are not synchronized, and ArrayList use indexes, of course, but linked list does not have any indexes. These comparison tables are really useful because we have already learned about ArrayList and also linked list separately, but when they come to the same picture, it's really great to see the comparison. So that's why I have included this question. Let's move to the next question. So this one is completely new topic. How many types of exception can occur in Java program? So in the next a few questions, we will understand what are exceptions and how to handle them. Let's start. So there are two types of exceptions. One is like checked exception and one is unchecked exception. So checked exceptions is that they are checked during compile time. So what does it mean? That if you do not handle these exceptions, they will be checked and you will get compile time error. So that's why they are called checked exceptions. This one is also checked exception, but the other exceptions are unchecked exception and they are called runtime exception. So you can understand it in this way. Let's look at this arithmetic exception, right? You have variable a and you have variable b, right? Let's say that they are just numbers, integer numbers. Variable a is 10 and variable b is 0. Can you divide a by b? You cannot, right? You cannot divide by 0. If you try to divide by 0, compile will not complain about it. You will get arithmetic exception only during runtime. So during runtime, you will get an exception, arithmetic exception, complaining that you cannot divide by 0. So that's why, since they are not checked during compile time, they are called runtime exception and they are unchecked exceptions. It is the same for null pointer exception and other exceptions that have been given in this picture. And let's move to the next question and understand more about these exceptions. Explain runtime exceptions. If you are asked this question in an interview, you need to mention this part. If in the interview you mention that runtime exception are unchecked exception, that will let interviewer know that you know what you are talking about. And they can occur during the execution of the program. And we have already mentioned that unlike checked exceptions, which are checked at compile time, runtime exceptions are not required to be declared in methods throws. We should implement proper error handling and validation to minimize occurrences of these runtime exceptions. That means that if we know what kind of runtime exceptions are we gonna get, or like a possibility of it, so we need to handle, or we need to create some logics that will handle those exceptions so we don't have problems during runtime. So let's move to the next question and understand more about the exceptions. Is it necessary that each try block must be followed by a catch block? So the answer is that it is not necessary for every try block to be followed by a catch block in Java, but try block in that case must have finally block. So a try block either will have one or more catch blocks depending on the logic that you are trying to implement, or it must have final block, or it can have both catch and final block. But in a nutshell, a try block must have at least one either finally or catch block. So next question is, do multiple catch blocks order matter? And the answer is of course. The order of multiple catch blocks in Java does matter actually. When we use multiple catch statements, the Java virtual machine checks the type of the thrown exception against the types that's specified in catch block, but it starts from the top. It means if we have multiple exceptions, for example exception E and arithmetic exception, JVM will try to check if the exception that's already thrown is catched by this block or it's catched by this block. So order matters, and I will tell you why it matters. The first matching block will handle the exception and the subsequent blocks will be ignored. If you try to do something like this example, you will have compile time error. And the reason is that you see we have exception, but arithmetic exception is more specific type. Compiler will complain that there is no way to reach this catch block because it will always be caught by this catch block. So that's why it will say that either try to move it to the top or remove this arithmetic exception because this code is unreachable. Perfect. Let's move to the next question. And next question is, what will happen if you put system.exit on the try or catch block? Will finally block execute? So first we need to understand what system exit does. It exits JVM immediately. We know that when we have finally block, it will always be executed except one scenario. The scenario is that the finally block will not be executed if the system exit is invoked. So the way it is asked in interviews is that they will ask you, will finally block be executed always, or there are some exceptions? And there is. So you need to say that if you use system exit, as in this example, this will terminate this JVM, so finally block will not be executed. Let's move to the next question. What is the difference between following keywords? Final, finally, finalize. So final is used to declare constants, and final class cannot be subclassed. I mean, final can be used for variables, also for classes also. So if you have like a not, for example, class animal, the examples that we have checked, but if you add like a final class animal, if you create class in this way, that class cannot be subclassed. I mean, there cannot be any class that will extend that class. And if it is used for methods, it cannot be overridden. And final variables value cannot be changed. We have already mentioned it. Finally, it is used in exception handling to define a block of code that always executes after a try block, regardless of whether an exception was thrown or caught. But on the other hand, finalize, it is a method called by garbage collector. I have mentioned it in one of the questions. It is called before an object is reclaimed. It is used to perform cleanup actions like releasing resources, and it is a method that is defined in object class. Now we start one of the final topics of this interview preparation, and it is called what is multitasking. So what is multitasking? Multitasking is the ability of an operating system, or it can be a programming environment, to execute multiple tasks or process simultaneously. So it means that tasks can be executed simultaneously, so one task is not waiting for another task to be executed. So in Java, multitasking can be achieved using threads. With multitasking, you can achieve improved application performance because you will utilize CPU resources efficiently. So let's move forward and see what threads and multitasking means. So what are the two ways in which thread can be created? So in order to create a thread in Java, either you can create a thread by creating a new class that extends thread, and of course you need to override its run method. So here we have the example, my thread extends thread, and you override this run method of superclass, in this case, which is thread. So the run method contains the code that will be executed when this thread is. So this is how you can create a thread instance, and then you can use thread start, which internally calls run method. Perfect. The second way is you can create a thread by implementing runnable interface. And of course, this interface has also this run method, and we need to implement that run method. This approach is often preferred because it allows class to extend other classes as well. You remember that we said that Java does not support multiple inheritance. I mean, you cannot extend multiple classes. So that's why if you try to implement runnable interface, then you can use this myRunnable class to extend another classes, right? So, but if you try to follow the first way to create a thread, then you will be limited. This myThread class can no longer extend any other class. So that is the differences. Now let's move to the next question, and which is how can you synchronize an array list in Java? And if you want to synchronize array list in Java, there is already a ready method that you can use. It is called collections synchronize list. If you remember, we have already talked about unmodifiable list, right? So it is similar to unmodifiable list because it uses collections framework, and here you can do it like this. And you can use synchronize method, and you can try to access synchronize list and do some operations on it. So the next question is describe the life cycle of the thread. The thread has 5 main states. One is new, which is like when the thread is created, runnable, blocked, waiting, and terminated, which is the end of the thread. New is when it's created but has not yet started. So start method hasn't been called yet, if you remember our code example. Runnable is start method has already been called and it's already in runnable state. And blocked is a thread is blocked when it attempts to access a synchronized resource that's another thread already holding. And waiting, we know that we can use sleep method on the thread and it can sleep for some time. And terminated means it completes its execution or it is interrupted. So these are 5 main states of thread. What is garbage collection in Java? I think it is last question for this interview preparation, and let's see what is the answer. Garbage collection is an automatic memory management feature, and it helps to free up memory. Here the keywords is automatic memory management. That means that we don't have any control over it. So garbage collection happens automatically. It's not in our control. We cannot decide when object will be garbage collected. And of course it helps free up memory that is being occupied by the object. It deletes objects that are no longer accessible in a program. It prevents memory leaks and optimize available memory. So it means that we can have, like, for example, multiple objects, but they are not referenced by any variable, right? If they are not referenced by any variable, then why we need those objects exist in the memory? So garbage collector takes care of those objects and it frees up memory. Garbage collector runs automatically within JVM. We have already mentioned it. So developers don't need to do any manual work. If an object is unreachable, it becomes eligible for garbage collection. Perfect. This was the last question of this interview preparation. And I would like to thank you for watching this video. And if you have time, if you liked my video, don't forget to click subscribe, give a comment or like. It will help me to create other videos for you. So I believe that for whatever reason you are watching this video, it can be interview preparation or to refresh your Java knowledge, I know that you will succeed. Good luck in your interview, or if you don't have interview, good luck in your journey, and see you in the next video. Take care.